Do you hate having to type in passwords? I know I do. When you last logged in using SSH, did you use a password? What if I told you there was a way that you can log in with no password? Would you be interested? I bet you would. But let me go ahead and show you what it looks like, just so you know it's real. All right, here we go. We've got my Mac terminal here. We're going to go ahead and SSH into my home server. So what are we going to do? We're going to go ahead and put in our normal inputs there for SSH, and we're going to go ahead and hit enter. And oh, it didn't prompt me for a password. It is real. This is B from Talk Tech, and today I'm going to show you how to use certificates for SSH login. Stick with me. I have a favor to ask. If you like this type of video and want to see more content like it, make sure you are subscribed and hit the bell button for a notification. Also, don't forget to give this video a like if you like it. Let me know what you liked, didn't like, or if you have any comments, questions, concerns, or emotional outbursts down in the comment section below. And lastly, make sure you stick around all the way to the end to get the most out of this video. Let's do this thing. So, using certificates employs what is known as asymmetric encryption, which I briefly talked about in my previous video. Now, this involves a private and public key pair for the client machine. Now, a quick summary of asymmetric encryption is you're going to have what is called a public key, which is going to be publicly available to anybody, and it's going to be associated with the client, which is going to be you. And the private key is a key that's associated with both the client and the client's public key, but should only be known to the client. You do not want to share the private key. Never, ever, ever protect these with your life. At least your IT life, as far as these go, because you want to make sure that these stay secure, because this has huge implications if a private key is ever known, because then they can decrypt anything that's encrypted with the public key, and that's definitely what you do not want. So to authenticate to SSH with certificates, you will need to generate a public and private key pair, and then share the public key with the SSH server. Now, that is something I will be showing you today, so be ready for that. Now, what I want to go ahead and do first, though, is I want to explain to you how the process of authenticating with certificates works. So I'm going to go ahead and just pull up here a Word doc. There we go. All right, so let's go ahead and talk about the process of authenticating with certificates. So the first step, the client will initiate the SSH session by sending an ID to the server. The server then will check the SSH, it's going to check the home slash whatever your username is, whatever the username that you're looking for on said machine, and it's going to check in the /.ssh and the slash authorized key folder. It's going to see if it has it's going to check to see if it has a public key that's going to be associated with that client. And this is the file that will include public keys for clients that are going to be attempting to authenticate to a SSH server. So let me actually go ahead and pull up that file. Let's go ahead and go over here to the home server, and if we just go to cd.ssh, actually we don't want to do that. Let's just do cat.ssh authorized keys, and then there we go. We can actually see the public key that is associated with my MacBook that is going to be there in that file. So now if you go into the .ssh folder and you don't see this, that's just because you haven't set it up yet. So don't be alarmed if you don't see that. That is completely normal if you have not actually shared your public key with the SSH server. So, and just remember, we're talking about the client versus server. The client is always going to be you, and then the server is going to be whatever system you're attempting to access with SSH. So let's go ahead and go back over to the list here. Now, if the client is located in the file, a random number is generated and encrypted with the client's public key and then sent to the client. If the client has a corresponding private key, they will be able to decrypt it. If they don't have the corresponding private key, they will not be able to decrypt it. That's what's making this, that's why protecting that private key is so important. This is what makes it work. Now, the client will decrypt the number, combine it with the shared session key, which has already been generated. It'll calculate out a hash value using either SHA-256 or SHA-512, and then send it back to the server. The server then calculates the hash value And if it matches, the client is considered to be authenticated. So the client is in. So that's the process. When you saw me go into my SSH server, my home server, that's exactly what was happening behind the scenes. So I just want to go ahead and give you a brief summary of that process. So let's go ahead and go over here to this Debian machine that I have. Now, what we're going to be doing is we're going to be setting it up on a remote server. It's an Ubuntu server. Now, this process is going to remain the same for any type of, SSH server that you're going to be going into. But the first thing that we need to do is we need to generate the actual SSH keys. Because if we look here, we do if we just, we need to do .ssh, we can see here that it does have known host. So it has known host and it has known host old, but it does not have that authorized keys folder. So we know that this has not been set up here yet. So and that would be if this was going to be the SSH server. Now we're using this as the SSH client, so that's going to be different because we're going to be looking on the server that we're going to be setting it up on. Now, the server that we're setting it up on does not have that folder either. So let's go ahead and get things rolling here. So the first thing that we're going to do is we're going to go ahead and generate the private public key pair. So we're going to do sudo SSH key and then gen. We're going to go ahead and hit enter. We're going to put in our password. All right, it's going to give us these questions. Now, I always accept the default, so I'm not going to cover what these are here. Well, actually, I will, because if this first option here, it's asking if you want to save it to a different location other than the default location. You'll put that here. I would not recommend doing that. This is going to ask if you passphrase. Now, keep in mind, if you put in a passphrase, it's going to authenticate with the certificate, but it's also going to ask you for a passphrase every time you authenticate. So, and then it's going to just have you enter it again. This is going to show you that right there. It's going to show you the key fingerprint and all that stuff. And then go ahead and give you, and you can see there, it's got 256 RSA 3072. So it's very, very secure. That's actually where you want it to be as far as the standards go. So, all right. So now that we've got that, pair created. Now, one thing I do want to tell you though is if the keys already exist, they will be overwritten and you will not be able to use them for authentication. So you have to use the new keys and you'd have to go through the next step that I'm going to show you here in just a second again. But and again, I recommend sticking with the defaults as far as this stuff goes, unless you have some kind of business, or need for your personal self. And how we're actually going to do this is we're actually going to go ahead and use a command. We're going to use sudo. We're going to do SSH. We're going to just do tac copy. We're going to do ID. And then we're going to go ahead and, just as if we're SSHing into the remote servers, we're going to go ahead and put all of our information in. I think it should be 216. Whoops. Typed in copy wrong, and you probably saw that if you're watching at home. Right, there we go. We do want to go ahead and fingerprint it. All right, perfect. We're going to go ahead and put in our password. All right, perfect. Now it says, now try logging into the machine with SSH admin user, blah, 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 and check to make sure that the key you wanted was added successfully. So let's go ahead and do that. We're going to go ahead and go back up here. We're going to do sudo SSH. We're going to put in our username. We're going to put in our IP address. All right, there we go, and voila, we are now in our. Well, actually, I'm sorry. This is also another Debian 12 system. I had my IP addresses incorrect, but we can see that successfully went through. So we are now connected to the remote system using that certificate. So that's going to save us a bunch of time as we go in and out of these machines, because I do it quite frequently. And honestly, setting up the certificates is not something that I've done enough of in the past. So it's definitely something I'm going to do going forward, because it's really, really easy. And like when I first heard about asymmetric encryption and certificates, I was like, this stuff is crazy. Like, and it's awesome because you don't have to remember passwords and stuff like that. It's a great way to authenticate, and a lot of enterprises use this and stuff like that. But it can be intimidating. And the public key, private key pair kind of scenario is just not something that's very normal and natural to us humans, I feel like. But hey, it's one of those things that I'd be definitely willing to cover if that's something you're interested in. Let me know down in the comments. But this should save you a bunch of time when logging in going forward through SSH. Check out this other video on my channel Now that you finished this one, remember, mistakes make you better, so keep on making them. Thank you so much for watching my video, and have the greatest of days.